Got a pretty nasty looking quadratic equation here. It's a little bit scary because it's got an x squared on the left side and an x term and a constant term, but then on the right side there's also an x squared term. So it's a little bit intimidating because we've got stuff all over the place. When I see something like this, the first thing I want to do is try to clean it up. And by that I mean get everything on one side of the equation. So to do that, I notice that I've got 2x squared over here and x squared over here. So if I want to start canceling things out, I'm probably going to cancel the things out on the left side because I want to have a positive number of x squared. So what I mean by that is I can cancel this x squared by doing minus x squared on the left side. And if I keep things balanced, I have to do that on the right side. And this is nice because when I do 2x squared minus x squared, I'm just left with positive x squared on the right side of the equation. Okay, but that only cancels out this term here, so I also have to cancel out minus 2x, and I do that by doing plus 2x. And I can cancel out this plus 3 by doing minus 3 on both sides of the equation. So then what I end up with on the right-hand side, x squared plus 2x minus 3. And on the left side, it's just 0, right? All of these terms have been canceled out by their inverse terms, so we have 0 equals x squared plus 2x minus 3. Now this is nice because on the right side I can think of this as a quadratic function, and on the left side I have 0 here. So if I think about this thing as a function, which I'll just call y, if it's equal to 0, that means all I have to do is find the x-intercepts of this function. Again, x-intercepts are when y is equal to 0. And by now you're an expert at graphing quadratic functions. If not, just check out this video here. So I'm going to graph this and I'm going to do it pretty quickly just so that you can quickly review the process and then get to the solution. Okay, so I've got my parabolic function graphed here, and remember the equation we were trying to solve is when does this thing here, x squared plus 2x minus 3, equals 0. So what that means is we need to know when does that function equal 0. In other words, where does it intersect the x-axis? So it looks like, if I'm looking at these numbers here, this looks like minus 1, minus 2, minus 3, so that would give us x is equal to negative 3. That's one x-intercept. Over here, this looks like it's x equals 1, so that would give us another intercept. So we claim that these are two solutions to this quadratic equation. If you're not sure and you want to test them out, you can plug them back in here for x. So for example, if we make x equal to 1 and we put it in here, we would get 1 squared plus 2 times 1 minus 3, which is equal to 1 plus 2 minus 3, which is equal to 0. So that's how we can check to make sure that our answer is correct.